We'll be going over problem number 41 on chapter 10, and the problem reads that one study reports that 30% of newly hired MBAs are confronted with unethical business practices during their first year of employment. One business school dean wondered if her MBA graduates had similar experiences. She surveyed recent graduates from her school's MBA program and found that 27% of the 120 graduates from the previous year claimed to have encountered unethical business practices in the workplace. Can she conclude that her graduates' experiences are different? So to start off with, we want to state the null and alternative hypothesis. The null hypothesis is denoted as H naught, and in context with this problem, we can describe it as H naught is the NBA students are exposed to unethical business practices at a similar rate to others in a program. And if we want to input our hypothesized value, we will denote H naught as P is equal to 0.3, where P is equal to the population proportion and 0.3 is the hypothesized proportion. Once we state the null hypothesis, we want to state the alternative hypothesis, which is basically what we're trying to prove. So in context with this problem, we state that the alternative hypothesis is as follows. HA is the MBA students are exposed to unethical practices at a different rate to others in the program, and if you want to input the hypothesized proportion, it would be denoted as HA is P is not equal to 0.3, where once again P is the population proportion and 0.3 is the hypothesized proportion. So now that we studied the alternative and null hypothesis, our goal is to find a p-value, but in order to find a p-value, we have to create a jump data table because we can't find a p-value by our hand. We can, it'll be hard. So you open a new data table and you click on column 1, and you want to give column 1 a meaningful name. So I'm going to name it for this problem unethical business practices. And in the columns we will say either yes or no, with yes being either 1 and no being 0. And if you note that the unethical business practices is denoted as a categorical variable, that is why it is in a red bar. So then you want to make a second column and title this a meaningful name as well, but this one will be called our count or our frequency. And in order to find our count and frequency for this problem, the problem states that 120 graduates, 27% of them experience unethical business practice. So in order to find the yes count, you would multiply 120 times 0.27. which will give you 32.4, and for this problem purposes, just round down to 32. So now that we have yes, we can find no by subtracting 120 from 32, which gives us 88. So now that we have our data table set, we want to analyze and we want to use a distribution module to find our p-values. So we go to Analyze, Distribution, and we will put our characteristic of interest into our y columns and our count or frequencies into our frequency column. So then we press OK, and then you notice now that JUMP will give you a bar chart with our summary statistics. So we can see that there's 88 out of the 120 that do not experience unethical business practice, which is a frequency of 0.73 or 73%, while yes experience. There's 32 that do experience unethical business practices for a 27% frequency. And we note that we can't find, the p-value is not given here, so we have to go to our hotspot under unethical business practices, go down to test probabilities, and this pops up. So we want to insert our hypothesis proportion, and in this case is 0.3 into what we're interested in, which is yes. So we will enter 0.3 into our yes column. So now we want to select an alternative hypothesis for testing probabilities, and the probability is not equal to hypothesized value is equal to a two-tailed test, while probability greater than hypothesized value is for a right-tailed test, and the third being less than, which is a left-tailed test. And for this problem we are interested in not equal to, so we will choose the first one. So then we press done, and we can see that we're given p-values here, but there's two rows, so we are interested in the Pearson column, not the likelihood ratio. And remember that the p-value for this hypothesis test is 0.4256. Since the p-value is relatively large and greater than our alpha level 0.05, we failed to reject the null hypothesis. And when our p-value is large in this case, there is little evidence against the null hypothesis, so this is why we failed to reject the null hypothesis. It doesn't necessarily say it's true, it just says that we don't have enough evidence against the null hypothesis. So now that we have our p-value, we can make a conclusion. So since we failed to reject the null hypothesis, we cannot conclude that the rate at which these students are exposed to unethical business practices is different from that reported in the study. And you want to make a note that just because we failed to reject the null hypothesis, it doesn't necessarily mean that the null hypothesis is true. It only means that there is no evidence that the alternative hypothesis is true. And that is it for problem 41 on chapter 10.